Hi everyone and welcome to today's webinar. This webinar is on low-cost cargo delivery drones, presented by the team of Zambia Flying Labs. And what we're going to talk about today, the current challenge with cargo drones is that many are either too expensive or complicated to use. Some can only do one-way deliveries, others are still prototypes or are really designed to serve large populations. This means that smaller and more dispersed populations do not benefit from aerial deliveries, and smaller organizations, particularly in the global south, may not be able to afford some cargo drones due to the high cost. This webinar today by the team of Zambia Flying Labs will address some of these issues from a local context point of view, addressing how to build low-cost and high-performing fixed-wing drones, which can then be used for different applications, such as delivery of goods, large-scale mapping, and so on. Today, Chitula will present this webinar, followed by a round of question and answers by Kelvin. So over to you, Chitula. Thank you very much.
All right. Thank you for that introduction. And my name is Chitula Lukonde. I'm the coordinator for Zambia Flying Labs. And with me is Kelvin Lungu. This is the operations coordinator at Zambia Flying Labs. So today we wanted to share some of one of the research projects that we've been working on. But before I do that, a brief of background. I think as most of you might be aware, I think We Robotics has been making strides where cargo delivery is concerned. So it was actually a few years back when I read about a project that We Robotics was doing to do with repurposing cargo drones for delivery. And that really got us very excited, and actually we are very pumped to say I think we can also try something like this as a research project. But then when we went online to check for the repurposed drone, it was in the tens of thousands, the M600. So we were very excited. We thought this is a very brilliant idea, and at that point we first put it aside to say, okay, I think we can maybe save something and then come back to it and repurpose our drones and test this. Then fast forward, after some time, I started discussing with my partner Kelvin, say maybe there's another way we could build a very low cost, high performing platforms that we could use, and possibly for much cheaper price as we'll be presenting. So basically this is the background about this project. So now the objective for this project now for us became how do we beat the price? How do we create something that is affordable without compromising on performance and safety? So the objective was simple, to create a low cost but high performing fixed wing based platform for cargo delivery. Now what problem statements are we dealing with? As I mentioned in my introduction, one of them is the high cost for cargo drones for the global south. If you live in a place where I am, I think the amount that some of these repurposed drones would cost is slightly higher, considerably higher. So that's the reason why we thought maybe, in addition to the already creative solution that is already existing, maybe we could propose another path that could be exciting to some flying labs in order to venture into these cargo drones, which is in fashion right now. Then the other aspect is we needed to build something that is high performance, because when you compromise on price, you have to be very careful, and where you use two words, performance and safety. you need to be careful because where you use those two words, price is affected. You would push that further away because you need more higher capacity batteries and more equipment that will ensure that you are safe for other users of the airspace. What are some of the key considerations did we factor in building this low-cost drone? One, there are four factors that we based our judgment on. One is public safety. Whether you decide to build your own drone, this is something that you should not neglect. As a matter of fact, I strongly believe that as Flying Labs, we should be championing in our respective countries in pushing for the use of safe drones, because it only takes one silly mistake and you find there is a change in policy and everything is affected and other drone users are affected. Two is platform performance. We wanted to achieve the desired performance in terms of longer flight time, also in terms of the cargo that it can carry. Then three, regulations. In Zambia right now, we have a very good regulation system in place, and some of these things are provided for. But the only challenge is that if you're relying on open source softwares, it's prohibited, although not written, but verbally, it's being communicated to. So that's another principle, that's another consideration that you have to factor in, that if you're going this route, you also have to think about your ground control softwares that you're using. But there are many out there, most of them are open source, but you need to think about how do we make something that you could own. Then the fourth factor is flexibility. We need to make sure that our platform is as flexible as possible, that allows for different payloads that it could load on that particular platform. So having considered these four items, we went ahead and me and Kelvin, we decided we're going to spend about $2,500 to make this possible. So we went on the market, looked for the cheapest but reliable airframe from FE Believer, and some of the specs that we managed to achieve is that we now had an endurance of 95 minutes. That's when you're using a high capacity battery, the 6S, 25,000 milliamps hour with no payload. And we're looking at the range of 20 kilometers to 60 kilometers delivery range. So now before you, if at all you ever decide to build your own drone, there are a few considerations that I think are standard. And I feel at this point, when it comes to building a drone, it's not that complicated. And the reason is simple, because in most cases, you're not building a circuit. Rather, you are putting together different subsystems of already made circuits to achieve your desired outputs. So my diagram here shows a schema for different items that are configured for our plane. And I'm sure if it's a similar architecture to most of the drones out there, whether you're looking at a regular fixed wing drone or a VTOL, similar concepts, the science is almost the same. So what are some of these subsystems that will ensure that you have the basic flight without factoring in the payload and whatnot? First of all, you need a telemetry system. So the telemetry system unit essentially enables communication with your ground control station. The ground control station is something where you'll be able to see where your plane is, and also that fancy grid that we see as it's moving. So basically that's your that would constitute the entire telemetry setup. So on the drone, there's a unit that has to communicate with that. Then you have the flight controller unit. In our case, we use the Pix Hawk flight controller unit, which is a small circuit board of varying complexity. In simple terms, it simply manipulates motors and servos accordingly. Then you have the receiver. So if you are the pilot, then you're sending those signals. So this little device here, or this sub module, receive and identifies the signal, then it sends it out to the entire circuit. And the battery, this is basically your life force of the drone. And the science is straightforward. The higher the capacity, the longer you can stay in flight. Then you have, just after the battery there, you have the power distribution, which essentially, this is the board that splits all incoming electrical power feed into multiple secondary or subsidiary circuits. And the idea is simple. So most of these electronics that you have on board, they receive different power distribution. So you want to have this board to distribute these channels for you. Then you have the ESC. So ESC is short for electronic speed control. What this does, it controls and regulates the speed of electric motors. So this is connected to, it's got its own rating, and it receives commands from your flight controller unit. Then the servos. So as you can notice here, we have these two types, aileron and elevator. So these are small inch devices on an aircraft control surfaces to assist the movement of control surface. And the other component is the BEC. BEC is just a fancy word for what some of you might know as the voltage regulator. So what this does is that it just feeds some components with the required voltages. And then the most very important component here is the GPS unit. So this allows drones to know their location relative to a network of orbiting satellites. So that's why you're able to do funny things like position hold, autonomous flights, return to home, waypoint navigation. So this is the unit that makes it possible. So just to run you through what this diagram means is that our flight controller here that controls, manipulates these two items, the motors and the servos, and also this interprets these, communicates with your control ground station via the telemetry units. So this has quite a number of ports that you could configure accordingly, but at the barest minimum, these are the required components that have to be connected to the flight controller to ensure a smooth flight. I mean, if you want to put your camera there or whatever else, it also feeds into this. Then when it comes to cargo payload, another economical or cost-effective choice would be 3D printed casing. The reason is simple. 3D printing is very cheap. You can get a decent 3D printer for as low as $400 US. It's cheap, it's flexible in terms of the different shapes that you could print. So if you're dealing with the test tubes, I would imagine you can create a very nice casing for it. And also, you can design something that allows for automated release mechanism using servo motors connected to your flight controller, so that you have a nice release mechanism whenever you're transporting something. So there's a lot of things that you can be configured to this. Another thing to note is that why this might seem complicated, but it's extremely straightforward, is that most of your time is spent on configuring rather than worrying about the circuit. If you know what the circuit does, it's very straightforward to come up with something like this. Then whenever we talk about building custom drones, one of the things that shouldn't be neglected is safety and regulations. And if you are thinking of building high performance drones, you really need to think about this very critically. And one of the important factors that you have to factor in is the transponder. In the drones that we are familiar with, you are probably well acquainted with terms like DJI Sense. That's basically a transponder that allows you to receive signals from other aircraft nearby and visualize their position. So when we talk about safety, it's within the context of making sure that or respecting other users of airspace as well. So it's not just you seeing your drone navigating through those waypoints. It's not enough, but also the ability to see other airspace users and also to be seen. So far on the market, the most common solution for this is we basically, as the drone operators, we are the ones that see planes. So our most planes out there, or most recent drones, they are coming already equipped with this, where you're able to see other aircrafts nearby. But if you use your own, there are also alternatives to this. This is a cheaper solution. It's called Ping RX Pro. It's very compatible with the Pixhawk flight controller, as well as other brands on the market. It's about 300 US dollars. So what this thing does is got a very high range. So within a radius of 278 kilometers, it could sense any airplanes that are around. But this one, it only it's a receiver. So what that means is that it's able to read frequencies for the planes that are nearby and visualize them on the map. So you're able to view the positions of different planes that are moving around as you are flying your drone. So within this range, you're able to see different drones. And the intensity of this coverage diminishes as you go out there, as depicted by these color bands. Then, depending on what regulation demands, sometimes they might also request that they also want to see where the position of your drone. Now, this might be an option for some of the people that might be interested in doing this, or it might be mandated. It depends with what your regulation says, but most of the times it's not a requirement where you can buy this. But the problem is that once you buy this Ping 200 XR, it pushes the cost extremely high, because this component alone is around 2,500. What this thing does is that it enables airspace access, the regulators and air navigation service providers acceptable worldwide, and then it enables your aircraft to be detected by secondary surveillance radar, traffic collision avoidance systems, and ADS-B in receivers. So what this essentially means is that if I have two planes where one is equipped with this and I have my drone that is equipped with this, I'm able to see the position of one who's equipped with a receiver. However, and this person can see me as well. So the roadmap is been very simple. We have not done an extensive test, because we're working closely with the Civil Aviation Authority. So the only thing that we've done mostly is calibration, which was done on the 1st April with no payload. And the second test schedule is scheduled for 30th October with a payload. And then we have a stakeholder meeting with Civil Aviation Authority. And then from there, you'll be hearing of Zambia Flying Labs doing actual cargo delivery system if all our plans work out. So this was the short and brief presentation I had. I think we'll have more feedback, questions. Thank you.
Thank you very much, Chitula, for this presentation covering different aspects of the cargo drones, ranging from technical details to safety and regulations. The team of Zambia Flying Labs is now open for any questions. We'll have a short Q&A session. Does anyone have questions for the team? I see a raised hand somewhere. Feel free to go ahead. Jamal, I think you have a raised hand.
Thank you very much, Jill. Thank you for the team for this presentation. This is great to see this presentation. So I have just one proposal for the team. When you have presenting the schema for Vital, the slide number five, 5 or 6, you have a present the schema with all components. This will be grateful if we have a list of material that we can use in each part of this schema. Can we have that?
Oh yeah, yes, that's possible. I think it's not a problem.
Okay, that will be great. That will be great. Thank you very much.
I see, yeah, more hands. One from Haiti Flying Labs. Cesar?
No, sorry. It was a mistake. Sorry, you can continue.
No
Thanks.
worries.
Okay. Yes. Good morning or good afternoon to everyone. Thanks again for your presentation, Chitula. It was very, very interesting. Yes, actually, I am a net traffic controller, so I understood everything related to TCAS, ADSB, and yes, everything. And also, I am a drone software and system engineering. So I liked your presentation related to the schema when you talk about the Pixox, the ESC, the motor, the servo, and everything. Here in Cameroon, since 2 years now, I've been actively working with the University of Yaoundé 1. So I've been lecturing there for the past 2 years in drone software development. So the idea here was to provide the students with solid understanding of the drones, the core system of the drones, as you just mentioned, the Pixox, because there are several flight controllers, but the Pixox one is, as you said, is open source. And here we are using CrazyFly. CrazyFly is one of the best drone open source platform for drone development. And yes, I really like what you guys have been doing in Zambia. And my suggestion is this: I'll be willing to work with you if you don't mind, because in Cameroon, as I said, we have been working for the past 2 years in drone development, but we've been using CrazyFly. As I said, CrazyFly is the open source drone platform for drone development. And as I said, I'll be really willing to work with you if you don't mind. So that was just a suggestion.
Okay. Yeah, I think that's a very good idea. I think we're open to such collaboration, and I think that was also the goal of this webinar. We wanted to get feedback and also learn from other experts in terms of this is the right direction. So I think we're open to such collaboration. I think I'll reach out to We Robotics. I will see how we can collaborate.
Okay, great.
Thank you very much. And yeah, happy to connect you as well. We have a comment from Diana from Zimbabwe Flying Labs. She's saying, thank you for the presentation. Well done for the progress so far. Have you identified a route, and what will you be carrying?
Okay.
Can I come in on that one?
Yes, please.
I think it's a twofold. This presentation actually, following this presentation, I think Mr. Chitula mentioned that the first thing that we've been looking at is quite all right in terms of how we can repurpose the drone. So our main focus for starters was medical cargo delivery. I think we did prepare something which was not shared for this particular presentation on how we can repurpose such drones for health robotics. So we actually have a PowerPoint on that for those who are interested. Regarding health robotics, one area that we are focused on is rural areas. And because it's rural areas, one thing that we looked at in terms of safeguard issues is what is called corridor mapping. So this is something actually that's been done in Malawi, where you'd find that you map certain corridors of busy routes that you'd be using for deliveries, for instance, for health. For instance, we have got health posts just within Zambian rural areas that you'd find become an actual route that you'd be delivering more frequently. So it becomes a corridor that is recognized by the aviation authority. And what that does, it also helps you in terms of authorization, because we have a problem in Zambia when it comes to just authorizing a flight. You'd find there are so many processes, and sometimes you'd need maybe authorization should be done promptly because it's an emergency flight, for instance. So with regards to that, one safety guard that we looked at is what is called corridor mapping, where you have got predefined routes for predefined areas, which are actually captured under what is called the health robotics scheme, which we are trying to propose also. So we're looking at not just the physical building of the drone, but also looking at the social inclusion, environmental inclusion, the community inclusion, looking at all those aspects in terms of actually making something practical. So because of that, all defined routes which we have actually not really established, but we have established rural areas that we are targeting within Zambia and looking at medical cargo delivery. So once we have some stakeholders who have already proposed to come on board, that would be able to help us, including our Ministry of Health and also USAID, hoping some of those proposals go through. We are trying to push for them side by side. And I think that's why Mr. Lukonde also said that we're open to collaborations in the long run, because we're looking at also how we can implement this in the global south, in other countries, be it Zimbabwe, be it Brazil, be it Argentina, in other countries that are facing similar problems, and see how we can collaborate in implementing something that suits regulations and suits also the practical implementation. Thank you.
Right, thank you very much, Kelvin, for answering that question. And we have Patrick with hand raised as well, and a question.
Thank you. This is really great work. It's really exciting to hear. So just to say, keep up the good work. If on our side of We Robotics, we can provide any kind of support, obviously with the engineering team, if you ever wanted to pick their brains, I'm sure they'd be keen to also speak with you and learn from your experience, because ultimately, you know, we're really keen to have be able to source cargo drones from more locally and more regionally. That's really the whole vision. So, you know, if there could be cargo drones made in Zambia that could be used in the region and rest of Africa and possibly, you know, beyond, you know, we're always looking for that. And then just as a side point, that I've been facilitating an informal working group of locally owned cargo drone startups. We've been meeting multiple times a year for the past couple of years. It includes startups from Nepal, India, Kenya, and Senegal. So if you wanted to join that, it's an informal group. Members present their work, their tech, and it's really meant to be a group for these startups from these different countries to help each other out on technical questions, marketing questions, training questions, and so on. And the idea, the vision, ultimately, is to form a kind of a trade association of locally owned cargo drone startups to better represent the interest of these startups with respect to donors and clients and so on. Again, it's informal, it's voluntary, it's it's not something that we formalized just yet. Anyway, I'm sharing that because we do meet every few months, and if whenever you feel like you could gain something by contributing and or asking questions, simply just reach out to me and I'll add you to the thread. Thank you. Thanks again. Looking forward to how things go in October. You mentioned the test and so on. So
thank you very much. Thank you.
Any other questions for the team of Zambia Flying Labs? If not, I have a quick question, and I was working just behind the scenes while you were presenting, so my apologies if you've covered it already, but do you have some more information on the payload capacity?
I think, hello?
Yes. Hi, Chitula.
Yes, I think we didn't include that, but in our calculations, without the payloads, the flight time is 90 minutes, but with a payload of between 5 kgs to 10 kgs, the payload reduces to, the flight time reduces to 75 minutes. So I think we're still doing our homework there. I think it won't be.
So maybe to come in also, what we're trying to do initially, I think even in our first few slides, I think Mr. Lukonde mentioned when we're choosing the frame itself, we looked at, first of all, something that can house, even if we're to 3D print something, it could house something that is quite big. But when we do our tests, because we have made it in such a way that we will be flexible in terms of the casing. So we're going to 3D print and test and also put some samples, which we are going to carry and test. So it will be a matter of iteratively checking based on this payload, what does it carry? So we're going to systematically be able to try to see based on the maximum payload it can carry. But realistically, the payload I think that we had looked at was payloads that are specifically to health, which will not really affect the flight time. And if we go as far as 10 kgs, which is a lot, then it will reduce, but not significantly reduce. Because initially we were looking at, if you are, for instance, carrying payloads like medical supplies, payloads, for instance, such as if it's ARVs, tests for ARVs, for HIV, because most of our health posts in rural areas, actually, their agency are things to do with lab tests, are things to do with medical supplies, which are not heavy payloads, because you'd realize that our roads are very poor. So you'd find just to have that medical delivery that is urgent or an emergency, we end up losing out. So we looked at, first of all, emergency deliveries, which actually the payloads don't even go as more as 2.5 kg, maximum is 5 kg, and see how that can be done. Then we're going to now see, based on different tests and simulations, based on the actual flight simulations within the actual flight. So not just from our results, but based on what we have planned, we now do those tests and do those simulations in real flight time. So I think, as Yaz mentioned, we're looking at, no matter what payload, if it's maximum 20, we should not reduce to half an hour or lose 50% of the flight time. So it will be a matter of also trying to see what we need to compromise on this and that to try to save. Do we need to try to maybe use a lighter frame? What will be the complications of that? So as we have said, I think it would be very good, as you have suggested, just to try to research it out in actual practical tests and runs using 3D printed casings and simulated materials that will be carried based on tested flights. Thank you.
Right.
Because also safety is an issue. You'd find that casings, we need to see how can we fix the casings for some delicate things like test tubes and the like. So it will be very interesting. It will be a very interesting run when the payload comes into play. Thank you.
Right. Thanks, Kelvin, for that information. And there's also another question from Paulette Elliott in the chat. She's asking, how do you handle or manage the security and safety of the payload?
Okay, so thank you for that. So for now, one thing that we're looking at is we're not looking at the release type of payload. So for now, we're looking at the lock type of payload. So where you're able to lock the payload to the drone, that's number one. Number two, we're looking at how we can encompass it inside the drone itself. So the biggest challenge that it comes to safety of deliveries is hacking of your drone. So that is one thing that I think that we're saying, the software itself, the programming itself has to be something that you have to really try to see how you safeguard that. But in terms of, I've noticed there was someone who mentioned to me that last time actually a drone was hit. I don't know if someone aimed with it with a stone or something. That's the reason why these are called beyond level of sight drones, which actually you'd realize that they are not flying at a low level. And that's the reason why even Civil Aviation Authority is being involved. There are issues to do with transponders because you're trying to keep the safety of the drone by having it beyond level of sight, but again, not being in the path of main aircraft. So that is one safety approach we're trying to look at, apart from also locking the casing. But having it beyond level of sight is one safety precaution, and also locking the casing. Thank you.
Thank you. Thank you very much, Kelvin, again. Any other questions for the team? If there are no other questions, then we may be wrapping this webinar today. I don't see any hands or comments, so yeah, I think we can close the webinar. Thank you very much again, Chitula and Kelvin from Zambia Flying Labs for presenting this webinar today. And we're looking at connecting you with different stakeholders as well as per this call. Thank you very much and have a good day, everyone.
Thank you very much. Thank you for having us. Thank you.
Thank
Bye.
you. Thank you for having us.